Go ahead and start my presentation and start from where we left off yesterday. Okay, and just give you a quick overview of what we talked about yesterday. And this is amazing things that I'm teaching you. Take advantage of these. Um, Yesterday, we looked at the definition of IT, and everybody knows what IT is: information technology that makes us do our jobs, right? Anything that you touch today is based on technology, whether it's a healthcare industry, whether it's a car industry, whatever industry you're part of, the technology is there. So what are the core components of technology? There is a hardware element, there is a software element, there's a networking, there's a data, there's a security. We can talk about that. Security falls under the software aspect. And then we talked about the hardware elements in the IT industry. We talked about there are computers, there are servers, there are networking devices, and there are storage devices, right? And then we talked about the basics of networking, and I specifically talked about the devices like servers, laptops, desktops, how these devices get connected to the switch, and how so devices get connected to the switch. Switches get connected to the router. So when devices get connected to the switch, they form a network. When switches get connected to the router, they form they connect networks. So switches create a network. Routers connect those networks together. Network A, network B. You want to talk to each other? This machine on this network, this machine on that network wants to send messages to each other. They want to access a website over here. They want to send a file. They want to exchange some information. There has to be a router in between. Now, this network wants to talk to this network. There has to be a router in between. So the routers connect networks. Switches form networks. Routers connect networks, okay? And firewall is in between to protect, to block the unauthorized access. I know I'm repeating a lot of the information. Again, the same slide over here, and then we looked at the very basics of networking. Some every node. Remember, I talked about the node. Every machine, a device rather, on a network that has a logical address, which is the IP address. Every device on the that can get on the network has to have an IP address. And once it has an IP address, it becomes a node. We refer to it as node. So the IP address, think of it like your logical address is your social security. Your phone's logical address is the phone number. That's how you reach other phones on the network. Just like that, every computer, every server that has a network card gets an IP address, which is the logical address, unique logical address for that network. And then we looked at how these networks connect, and take a look at this. This is a node. Once again, node. Any device that gets an IP address is a node. I can call it a device, I can say server, I can say laptop, but then I'm being very specific. When I say node, it means I'm talking about generally any device that has an IP address. They get connected to the switch gets connected to the router. So this is a network because the switch is here. Now this A network can talk to this B network because of this router is there. So router connects the networks. Okay, understand that. This is going to be on the test. So now let's continue. Let's continue. What I did was basically I came up, another thing, important thing over here. So now every network, every machine, every node that wants to communicate on the network needs to have a network card. It needs to have this configuration. It needs to have an IP address. It needs to have a subnet mask, and it needs to have the default gateway. These are the numbers that you put in some configuration. There's a file, you open up that file and you put in these numbers over there. And this is the way the network card now knows where to go, where to send the traffic. And if you don't understand this network configuration, you cannot be good at networking. You cannot put your machine on the network. And now some of you are going to think, how is it that my machine is working on the network? It's online. I'm able to see you over Zoom. That means I'm connected, I'm online. How is it that I never had to enter all of this information? That's because it's done for you automatically through a router that's in your home, which is taking care of that. And you don't realize that. Okay, so let's move forward over here. And this is how this information looks like when you plug in this information. And down the road, I'm going to show you where to pull this information for your machine. And then we're going to use an IP address to connect to another server, which is going to be fun part, which I'm really looking forward to. So this is how the IP address looks like. Unique number. Once again, the subnet max defines your network, your subnet that you're on, how many machines you can have. I'm going to explain this in detail when we get to the networking. Default gateway is another number. That's a gateway to your network, like a router that brings in the packets and takes the packets out, brings in the information, takes the information out. And here's a map, a beautiful map, which I always used to think, hey, how is the internet coming into the building? And working for a Fortune 100 company at AT&T, I had an amazing opportunity to set up the network from scratch when we took over this building, 33 Thomas Street. 33 Thomas Street in New York City is a strange looking structure without any windows, and it's very tall building in downtown. If you watch a video on the YouTube, you'll see my Mercedes parked over there in the parking lot as well. So ISP, the internet service provider, gives you the connection, just like you for your home. When you call Verizon, Comcast, or Roadrunner, whoever your internet service provider is, they will come to your home. They will give you one cable, which is basically bringing the internet to your home. For the enterprise, for the Fortune 100, 500, or enterprise, it's the ISP that brings the fiber to your building. And then there's a demarcation point over there where they basically says, hey, this is where I've installed the fiber. From here, this cable is going to go into your router, which is called the edge router. And then there is another device which is on the network, which is the firewall. This is a physical device that basically it's like a security guard that checks all the incoming and outgoing traffic, and it blocks the threats on your network, so it keeps you safe on the network. And then your router is connected to the switch, and then the switch is you connect all your devices to the to your switch directly. And we already talked about the switch part. And so this is a complete picture of how the basic networking work. And number of switches explode, number of routers explode. Usually when you're working in an enterprise level, where for a Fortune 100, 500 small mid-sized company, there's not a one switch or router that you're working with. It's hundreds of switches, hundreds of routers, depending on how many devices you have on the network. Okay, so this is a bigger picture for you guys to understand. Then we jumped right into server. What is a server? We talked about a server is basically a role. Just like you humans, right? We live in our household. We have a role to play, and we may have multiple roles to play. For somebody, I am a brother. For somebody, I'm a son. For somebody, I'm a husband. For somebody, I am a father. And for somebody, I'm a friend. So server basically is a role. It could be a physical server. It could be a software-based server. It basically serves something on the network. But usually when we refer to a server, it's basically a machine. Now now things are changing. When I talk about machine, It doesn't have to be just a bare metal physical machine. It could be a virtual machine as well. We will talk about more about this. For now, I'm going to stay on the bare metal level. So this server that you're looking at is specifically now called BM, bare metal server. And then there are other machines which are called VM, V as in Victor, virtual machine. We will talk about when we talk about cloud computing, virtualization is when virtualization is discussed when we talk about the cloud computing. So this bare metal server has a CPU, has a RAM, has a storage device, right? And then individually we looked at all of these components and their role inside the computer. And I have put together a slide for you over here that talks about every single part of your server. And so there's a cooling system which is installed right on top of your CPU so it stays cool, and the CPU basically executes the operating system and the user programs. Now think, so basically the way it works is this, okay? If I can just break it down over here because this is very important for you guys to understand. So now I have basically I have a USB drive, okay, and this USB drive is holding an operating system for me, whether it's Windows, okay, whether it's Linux. And now I want to install this into a bare metal machine. Bare metal machine being this box over here, okay, and this box. Mm, hold on a second. Why I cannot see my own video over here. Spotlight. Okay. So this box being the bare metal machine, and now this box has some parts, right? It has the SSD, which is the storage device, which means a hard drive. It will, when I install Windows or Linux on it, all the files are going to sit over here and all the programs are going to sit over here. Then when I power on this machine, what is going to happen is there are a set of RAM chips. This is memory. Now these files, one by one, whatever file is needed is going to be copied into the RAM. Copy means one copy here, one copy stays here, right? So think of it every time you click on the application that you want to use, Microsoft Word, Notepad, Google Chrome, Zoom, whenever you click on it, it is sitting on the hard drive. When you click on it, your computer automatically brings one copy into the RAM because the RAM is located right next to the CPU. And now because that file is closer to the CPU, then RAM feeds it into the CPU, and then it basically execute that program for you. And that's how, the information is thrown into the graphic card, which is, connected to your monitor, and that's how you see the results. You see a window pop up on your screen with a Zoom notepad. So it is very important for you to know the role of SSD hard drive, which stores the data, and it's a faster hard drive. Whenever it what is that? What does that mean? Is faster whenever you double click on something, it quickly copies files into the RAM. Now the RAM feeds it to the CPU. It's called the executing the instructions, executing the code, and then you see the display on your monitor. This is the basic idea of the bare metal server. And let's move forward and see the next slide over here. So this is where I talk about every single element of your server and their a little brief introduction, brief definitions of what they do. I'm not going to waste my time going over what we talked about yesterday. And now we're going to get into the software. All right. Software. Remember the three pillars of IT? Hardware, networking, software. This is where the software comes in. There are some software elements. Hardware, we looked at it. Network devices, we looked at your server, we talked about printers, whatever. Right? The next part is the software element. Under software, the biggest thing is the operating system. Operating system is basically a platform that runs your applications. And applications are the programs. These are the programs that you guys use on a daily basis. If you go to Zoom, that's one application. If you Microsoft Word, that's another application. Node, another application. Anything on your laptop or on your cell phone that you double click and open up is basically a program, and it has a purpose, what it does for you, right? These programs are usually stored on the hard drive. But when you go to websites, Walmart or TikTok or Instagram, all that massive amounts of data that sits on their servers, like all those videos that you watch, they are stored. They're not stored on a physical server hard drive. Physical server hard drive does not have that much capacity, so they are stored on external storage devices. These are gigantic storage devices. These are server looking boxes that are independently sitting. Your servers somehow through the wires connect to those storage devices, and those storage devices store data using databases. Those storage devices store the data using databases. So there are databases like SQL, MySQL, NoSQL, MongoDB. So these are some of the database related programs that manage the data and store the data, structured data, unstructured data. And this type of functionality is handled by database administrators, right? Operating system basically is the foundation. The OS is the foundation of the IT industry. And on top of the OS, when I talk about OS, I'm talking about Windows, and I'm talking about Linux, I'm talking about Unix. Okay. And there's also a Mac OS. Now, Windows is used in the industry at the user level, me and you using computer for our home things, to browse the internet, to use our applications. It is also used at the server level too. But honestly speaking, Linux is taking over that domain. Therefore, a lot of migrations are happening because coders, application coders that write applications, they are in love with Unix and Linux. First reasons, because Unix and Linux are the stable operating systems, and they have the flexibility to work through. Not that Windows does not provide you CLI, but they have better memory management, they have better file system, they are more secure, they're more robust, and this particular one is highly customizable, and I will talk about this, what that means, highly customizable, down the road. It has to do with the open source. I will speak about that. So OS is the core of the IT industry. On top of the OS, you have your application. You have your applications. These applications were developed by coders. Okay. And then on top of your OS, you also have some databases. And these databases basically store this app rated data right over here. And then these databases are basically stored on some external storage devices. They are sitting in racks. Right? These are some external storage devices. Okay. Storage. Okay. And so this OS, this databases, all of these things existed because of apps. At the end of the day, what sells is the app. You are a TikTok user. You're creating a lot of traffic on TikTok and Instagram. You go to CNN, that's an app, right? You go to, I don't know what other application you use. Microsoft Word, Microsoft Office. What are some of the applications that you guys use on your day-to-day basis? Okay. Can you please? So again, We're discussing the software element in the IT industry. We talked about the hardware element, we talked about the networking element, we talked about today we're going to talk about the software element. And in the software element, let me just erase this one more time and start again. And by the way, I'm going to make this video available for you guys maybe in a couple of days. So before you jump into my Wednesday session, you better watch this, because Wednesday is when we start applying all of this knowledge that we have into hands-on learning Linux. This is the fun part, okay? So in the software, I am talking about the operating system, which is the OS, okay? OS stands for operating system. All right. So when I talk about operating system, I want you guys to know that operating system is basically a piece of software that allows you to interact with your device. For example, this device that I have in my hand, it's an Apple iPhone device. It's made out of this plastic and metal. How did we put life into this iPhone that once I press this button, it glows, there's a light. When I swipe this, it takes me to my applications. All of the things that I'm seeing over here, they're all my applications. Understand that? So what makes this device run is the operating system. And what is the name of that operating system? iOS. Apple adds to everything iMac, iPad, iPad, iPhone. So the name of this operating system that runs this device is called iOS. So the name of the operating system that runs pretty much the IT industry is Linux. It used to be Unix, and there's also Windows. There's also Mac OS. Okay. Now, these two operating systems, Mac and Windows, they're very well known, recognized, they're user friendly. They are used by an average Joe, me, you, and anybody else that would like to use a computer, right? Regular users. Um, this, along with these three, is used pretty much. This one is used by regular users, Windows and Mac, but this Windows, Unix, and Linux, they're primarily used for servers. Okay. And I talked about the server and I gave you the architectural understanding of what's inside the server, the components of the server. So the operating system, everything, any application that you touch today is running, is at the end of the day, is sitting on top of this operating system. And the operating systems, it could be one of these, most likely one of these: Linux, Unix, Windows. I don't think Mac is at a server level. I have never seen Mac. I've seen sometimes, but no, pretty much all of these. Windows. I'm going to talk about the differences between Windows, Unix, and Linux down the road. Okay, I'm going to talk about it. But this operating system, if I go back to my slide over here, helps us to run multiple things. Mainly, it helps us to develop applications. So all of the development that takes place is sitting on top of the operating system. When I say development, meaning if you are a programmer and you know how to create applications, And there's usually not a one programmer that creates an application. There's usually hundreds of programmers that join together to create one application. And again, the application, if I look at my cell phone, I can see I have a YouTube, which is an application. I see I have a LinkedIn, which is also another application. I see Zillow over there, which is also another application, web application. And I see Instagram over here. I see TikTok over here. These are all the applications. I see Airbnb over there. And I see the banking applications are over there. So all of these applications were developed based on this application. You need to begin with, you need an operating system, and then you need the development platform. You need a development platform in order for you to create applications, apps. Okay. So again, the point that I'm trying to make is everything is sitting on the operating system. If you remove the operating system, the whole IT would collapse. These applications, this is the development platform, dev platform. Whenever you see dev, it basically means development. I'm sorry if I was going faster earlier. I thought you guys have the literacy of the, but I should assume that you guys don't have the fundamentals. That's why this class is fundamental. Anyway, so this is the dev platform. This is the development platform which sits on the operating system, and also programmers create applications which is based on the operating system. Applications store the data into databases. What are some of those databases? Microsoft SQL. Another one is MySQL. Another one, yes, Postgres. Another one is Oracle. Some of you guys know your stuff. SQL, of course. And so these are some of the examples of the databases. And MongoDB is another database. MongoDB. I have a student that works for MongoDB. I have a student that works at Oracle. Um, what else? NoSQL is also another type of database. And I mentioned that these databases are managed by DBs, DBA, database administrator. This alone is a different job title. Operating system is managed by system administrators, sysadmin. DBA again is another job title. Sysadmin. Applications are created by software engineer. We also call them coders. Again, this is another title. The databases also sit on top of the operating system. You need a platform. So essentially, This is basically a platform. This is the base of everything that you're going to touch. Okay. Storage databases, you don't have to know all of these things, but I'm just giving you a bigger picture. Databases are stored in physical devices. That's what called storage arrays. All right. And then you have racks of these storage arrays. Again, they are also connected directly to the operating system. Yes, I can share that syllabus with you guys. Once I share these slides, I will share that with you guys, what we will be covering. Okay. So again, who are these guys who manage these storage arrays? They are storage admins. Storage admins. Anybody confused on this? I'm just giving you how big the IT industry is. You know, in order for one application to be developed, you need all of these people. You need a system administrator who can manage the operating system. You need a developer who's going to write the application. You need a database guy who's going to store this application, the data. You need storage guys who are responsible for those physical storage devices. You need, and this OS is sitting on top of what? This OS. How is this OS connected to the next OS? Is the networking. So you need networking guys. And then you have your security guys to secure this whole environment. So app developers, system administrators, system engineers, database administrators, storage admins, network administrators. Okay. Everybody understand this picture? Everybody, this looks a mess, but if I remove, let me ask you this question. If something happened to my operating system, if this guy didn't do his job right, and this machine, this server, this operating system stopped working, what will happen to this whole ecosystem? Is this going to be functioning? Is this going to be functioning? Is this app going to be available? It's going to collapse. Going to collapse. Sometimes you click on your application and it says page cannot be displayed, a website. It could be that the problem lies with one of these things. Not entirely this thing. It could be storage, it could be database, it could be the application fault, it could be the security, it could be the networking. Everything is interlinked. Everything is interlinked. One thing is going to remain the same forever and ever: applications. As long as you and me, we live, we are alive, we're eating, we're healthy, we are going to use applications. Applications are going to explode. Number of applications are going to increase because not all the problems have been solved. If you look at the IT industry, what applications do? They solve problems, right? Uber came in. Taxi drivers, I was a taxi driver, and I know how difficult it was to drive around the clock to look for customers. While I'm driving, I'm also looking here, right and left, and on the corner, waiting for people to finish whatever they were doing, whether they were standing outside the restaurant and just park over there and wait for them to, say goodbye to their friends so they can come into my cab. Uber saw that problem and said, okay, customers are looking for yellow cabs or taxis. Taxi drivers are looking for them. Uber came in connected both of them using their application platform, and they created a $1 billion company out of nothing based on an idea thanks to the technology. All of these things thanks to the technology. So now applications are going to continue to exist. The number of applications that we create, they are going to rise because now me, you, or anybody can create this application. Try it for yourself. Go to Copilot or ChatGPT and explain your idea in specific details. You know who's going to be the most successful during AI era? It's somebody who can explicitly, specifically explain what they want. They can put their vision, imaginations onto a piece of paper, like the director does for the movie. And the AI will do that for you. But AI is not going to create those things in the space, in the skies. AI is going to ask you to do all of these things on the operating system. Operating system will still need storage devices. It will still need the database. It will still need the security. It will still need the networking. Cannot take it away. Yeah. Just like the babies don't fall from the sky, we were told when we were little kids. Just like that, operating system is not going to go away. The more applications explored, the more servers are going to be created. As we see today, Sam Altman building a $500 billion data centers. And what is the base of the data center? Networking, servers. And what do these servers do? They run operating system. Why? Because we can develop applications and we can run applications. What is application this Sam Altman is worried about? ChatGPT. For you, it's just an interface, a beautiful screen where you type your questions. For Sam, it's billions of dollars worth of servers, operating systems, databases, storage arrays to make that available to you. Imagine if more AI related applications come, we would need more operating systems, more servers, more networking, more Linux professionals. Linux is the backbone of the IT industry. We transitioned from bare metal to the virtual world and to the cloud. And Linux is the heart and the soul of the cloud industry. So go and check ChatGPT, what is the role of Linux in the AI era. So just wanted to give you this picture. I'm not sure how many of you clearly understand. Give me a beauty fly or ugly fly if we're having. How many of you understand this? If you understand this, this is a beauty fly, BF. If you don't understand this stuff, you say ugly fly, which is UF. Okay. All right. Just a shortcut. Okay. Somebody asked this question, why are we giving AI importance without human being? This AI is nothing. Well, you're right. You're right. You're absolutely right. We human beings will drive things, but you need to have that knowledge to coexist with AI. You understand that? Like I gave you an example of how many job market exploded in the last 15, 20 years because we needed coders. Tons of money were made to generate these coders, to create these coders. We fill universities with computer science students. But today's reality is whether you like it or you don't like it, AI is going to write that code for me. So now you tell me, is human talent replaced by AI? Alone, if you cut down that industry, the apps industry, the coders industry, it's a big dent in the industry because this was the darling of the whole IT industry. They ruled the IT industry. They demanded big dollars. Their average salary was $225,000, $250,000. So now, if you're telling me that you're still going to hire a human being to write a code for you when AI can do a better job, you're not living the real life. Okay. All right. So let me just take a second over here and erase all of this, and then we move forward to the next slide. Actually, we can just give me 1 second over here. Meanwhile, if you have any question, please type your question in the chat. I can answer that question. I want to get moving toward Linux. I want to teach you guys the basics of Linux. We're going to discuss the differences between these operating systems and why Linux is the darling of, why Linux is getting so much attention from these coders and from the cloud, and why it's becoming or has become the backbone of the cloud industry. Sorry, what's that, Rick? I didn't understand your question. Sorry. Could you repeat that? You would like to do what? You would like to hang around or you would like to say something? Okay. So let's take a look at this over here. I briefly talked about it earlier, and let me expand this to give you a little bit more understanding. Now that you understand that everything is based on the operating system over here, right? Um, you know that this is the middle point, right? You need an operating system to run system monitoring and performance because you have your resources being used. The security. So the basic role of the operating system is to provide all of this. It provides you file system management, resource management, interface between user and hardware, like I showed you on my cell phone, the metal device that I have. Interface means the way I interact with my device. So operating system is basically an interface between me, my is an interface to my device, right? And then it provides support for applications. It rather run applications, right? And it does system monitoring for you. These are some of the things that operating system can do for you. But honestly speaking, I showed you a beautiful slide earlier when I drew that what an operating system is doing for you. Operating system is basically, if I can come up over here with one node, maybe this will be a lot better for you guys to see. Operating system is basically the base, of whatever you do. You have an OS over here, and then on top of the OS, everything runs, whether it's application, whether it's database, whether it's a security, whether it's storage devices, whatever it is, it runs on top of your operating system. So operating system is a very important and vital part of the IT industry. We talk about the software elements in the IT industry. We are going to specifically put our focus on this part over here, the operating system, its role, and basically It's the platform that develops applications, that runs applications. Understand the uh, the stage in the IT industry. The whole stage is given to the applications. You guys use applications, average person use application, and that's how companies make money. TikTok, pays people to upload their videos, and if you many of you watch that, they get paid for that. And there are paid applications that you use. So you guys are generating a lot of income for those companies because you use their products, right? Like you use the Uber application to get from point A to point B. And so, briefly, this slide basically talks about the fundamental um, of the operating system, what its job is. Basically, its job is to store data. Operating system's job is to store data. Its job is to store users' information. Its job is to run applications. Its job is to secure applications. Its job is to provide a platform to develop applications. Okay. And then the fundamental purpose of the operating system is to develop applications. I was talking about how operating system is the basically backbone of the IT industry. Now let's take a look at what does the operating system do? What is its job? Well, its job is very simple. If you have a laptop, if you have a desktop, you have a server, you how are you going to communicate? How are you going to work with this machine? This is piece of metal, plastic. Yes, it has a CPU. Yes, it has RAM. Yes, it has hard drive. Yes, it has a network card, NIC over here. Yes, it has a graphic card. Okay. Um, yes, all of these things are there, but they are again, they are all physical phenomena, right? So, how do we put life? So, this is a server. For now, think of server as a metal phenomena, bare metal phenomena for now. But don't think that servers only come in metal boxes and heavy boxes. No, they could be virtual servers, they could be cloud servers too. We are going to explore that avenue as well. So server, again, what's the role of the server? It serves something on the network. In other words, if I Netflix, you go to Netflix application, right? It has all of those movies that you want to watch. Probably at the end of the day, it has bunch of thousands of servers in their data center running some sort of operating system and making those videos available to you. So they are Netflix servers. And when you go inside the Netflix data center, those servers have different roles. Some have are storing the name of the movies, some are storing the movie contents, some are storing your ratings, some are doing internal things for the company like authorization, security, keeping crucial files. And so server is something that serves a purpose on the network. It's a physical box for now. And how do you put life into this physical box? How do you interact with this physical box? What is it that once you press the power button, it shows up on the screen, the image shows up on the screen? Well, for that, at the very, very minimum, you need an operating system. So I'm going to call it an OS. you know, you need to install an operating system on top of this physical server. So this is operating system. Now, what is the role of the operating system? What is operating system doing for you? It is basically allowing you to interact with this physical machine, interact with this bare metal server. So it is the interface to this machine, right? It allows you to interact. When you press Control or Delete, you're interacting with your machine. When you go to your desktop and you click, you're running some applications. It runs some applications for you. Okay. It stores your data. The PowerPoint that I created is the data. I have it stored on my laptop. My laptop is running an operating system, right? It has your information, user information. Okay. The most important out of all is it runs applications. In order for it to run applications, it has to provide a mechanism to store data. It has to provide mechanism to secure that data. It has to provide a mechanism to make that data available to you. It provides you an interface to all the other applications. So servers run operating system. Operating system eventually allows you to develop apps, run apps, and keep your data safe. Application also has the data, right? And so that's the core function of the operating system. So basically, OS is managing your resources on the server. It's effectively managing your resources. Everybody's okay with this? It manages your resources. Don't pay attention to my spellings, okay? It's been a long time I graduated. It's been a long time I haven't done any writing. So as long as you understand what I'm trying to say, that's it. That's what matters to me. Okay. Now I'm missing a over there. It manages resources. What are the resources? CPU, RAM, and a hard drive. What does that mean? It manages your resources. Well, it allows you to save files on the hard drive. Fine. If I have my pictures, my data, my videos, I can save that on the server's hard drive because I have an interface. Thanks to the operating system that I have an interface. What I'm seeing on my screen is an interface. I can interact with my machine, with this physical laptop that I have over here. Some of you think I'm just sitting somewhere. Look at this. I have this nice Microsoft laptop and I am working on this laptop over here. So it allows me to save my files on the hard drive. Now, whenever I need to use a particular application, if I go over here, I have a Google Voice over here, I have a TikTok over here, all of these applications, I have Firefox over here, I have Slack over here. This application is stored on my hard drive in my operating system. I'm using Windows operating system, and it's just plainly sitting over there right now. And as soon as I double click on this, as you can see in my task manager over here, which is basically, a way to see all the running programs on your computer, task manager. Take a look at this. These are all the resources of my computer. I have two GPUs, which is advanced CPU. I have the Ethernet cable, which means I can plug in the Ethernet. are the wireless connection rather. I have memory, the RAM I was talking about. Take a look at it, how much RAM I have. Total 16 gigabyte, and I'm currently using 10 gig of that. And this is my CPU state over here. This is how much my CPU is being utilized right now, right? It's 20% utilized. These are all of my resources on my computer. And now if I go to the processes, which means show me all the running programs on my computer, it beautifully shows you how much resources are being used by some of these programs. What percentage of this program, for example, Google is taking 7.8% of the CPU, and it's taking 413 megabyte of RAM. And then right now it's not using anything on the disk, and it's utilizing 3.2 megabytes over the network, the speed, how much bandwidth it's using for my network. So if you see over here, I am not seeing any Slack application running. If I were to run over here this Slack, as you can see, the Slack is just probably sitting somewhere, not doing anything. And if I were to close this application, let's see if this will die. Yes, no, right now I have no Slack application running. So what operating system does for me in the background under the hood is whenever I need a application to run, I click on this application, or I can call this executing an application, running a program. I double click on this, and as you can see over here, now the Slack is running. And if you go to the app history or running processes, you will see an active process over there by the name Slack right over here. Now you see, Slack was missing before. Now the Slack is on the top. Now what the computer did for me is move the Slack files into the RAM. And now the CPU is also entertaining the Slack. Also, the memory is giving, now some of the memory is being used for Slack. So if I don't use this for a certain time, my operating system is going to forget about Slack. It's going to put it on the side and tell the RAM, hey, you know what? Don't worry about Slack right now. This guy is not using Slack, okay? He's using something else. Let's give our priority to that application. So very beautifully under the hood, this is what my operating system is doing. It allows me to store my data. It allows me to run my applications efficiently. It manages the balance, who gets the resources at what time. This is what my operating system is doing. And the most important thing is when I click on this, there's no more Slack over here. It's gone. As a matter of fact, it's running the process somewhere. When I just completely close this from here, it's gone. The memory removed the files. The CPU removed all the Slack related files. It goes back onto the hard drive. I mean, it was already on the hard drive. And now my system resources are not entertaining any Slack related files. So if you can see, I can have different users log into my computer, right? I can have local users, I can have remote users come into my system. So, and then, I can store files and set specific permissions on these files. So only certain users can open that file if I allow them. Does that make sense to you guys? Why we have the operating system and what's its role in the IT industry? If you understand it, then it's a beauty fly. If you don't understand it, it's ugly fly. Please pay attention to these concepts. They're very, very important. They're very easy to understand. You just need to open up your mind. Now, let's do a brief history. Now that we understand that operating system is playing a vital role in the IT industry and in the technology, and it is kind of the backbone of the industry. I can say that confidently. Especially, it is the backbone or darling for the cloud industry. Okay, that's definitely there. I know it's bread and butter for the cloud industry. So let's take a look at the brief history of Linux. This is the founder of Linux. His name is Linus Torvalds. Does it say somewhere over here his name? Yes, Linus Torvalds. So what he did was basically before he started writing the Linux operating system, there existed a Unix operating system. And like I told you yesterday, I had an honor to work for the company AT&T, which at that time was Bell, no, Bell Labs, and then turned it to AT&T Labs. This is the place where first networking operating system was developed. Before this, there was operating system which was not networked. Like these servers did not communicate with each other. These computers did not communicate with each other. So the scientists, the innovators, came up with an operating system which was in 70s, I believe. They came up with the operating system Unix, and Unix was the first network operating system. It helped run AT&T's, the whole infrastructure. It was needed for AT&T to have a network operating system. And then this operating system, we're going to talk about the difference between Unix and Linux. What he did was basically this Linux guy. He named his operating system Linux. So Lin from his name and the UX. He used from Unix, I guess, or from he got the idea. He named this operating system Linux. So this guy was a Finnish student, Finland. He was a PhD student, and he decided that he wanted to develop a operating system which would be essentially free for human beings. Great thinking over there, by the way. And more than that, he wanted to develop an operating system which is open source operating system. So in 1970s, um, 1970s Unix was developed. 1991 Linux was developed. Why was the need? Unix was powerful but proprietary and costly. So companies like HP, Sun Solaris, they were selling Unix operating system, and it was expensive for other companies to buy. Of course, everybody was buying at that time because you didn't have an option. So Linus came up with this idea that operating systems should be free and it should be customizable. And so let me stop sharing over here and come back to you guys on a screen and explain you. Okay. So operating system should be free and customizable. Okay. Free. Unix was expensive operating system. By the way, amazing operating system AT&T scientists developed, engineers. Amazing operating system. Till this day, some companies are running on Unix, okay? And this was the first um, major operating system that showed up. Unix 1970s, and Linus Torvalds came. He wanted to make this. Of course, this costed a lot of money for companies and also for consumers like me and you. Do you know that you're still paying for the operating system? How many of you guys know this? Every time you go to buy a laptop, desktop, there's a chunk of money that goes to the Microsoft. If you are a Microsoft customer, if you are an Apple customer, yeah, there's a lot of money going to the Apple as well. So yes, we are still paying for the operating system. We are so stupid. We have the free operating system, but we're still paying for the operating system because we choose to. Not that we choose to, we don't have a choice. We really don't have a choice, right? When you buy an HP laptop or Mac product, they don't give you a choice. You have to buy. It's all bundled in, right? So but Linus Torvald was a PhD student. He wanted to make the operating system free and customizable. What does that mean, customizable? Unix. Unix Windows, Mac OS. All three of these operating systems, the company ships you, and you cannot make changes to the source code. Remember this source code. What is a source code? A code that software code that that basically makes the operating system. Yeah, thousands thousands of programmers get together. They write millions lines of code in order to create a operating system, an operating system, right? So the source code is the code that you these thousands of programmers get together. They write pieces of code that's called source code that basically eventually create your operating system. Just like every application that you look at today, whether it's TikTok, Instagram, they have a source code. And that's the code that actually wrote that application. There's a bunch of programmers, thousands of programmers, right? So Unix, Windows, and Mac, they do not give you the option to view this source code, read it, let alone modify it. You cannot read this. You cannot modify. If you cannot read it, can you modify it? Absolutely no. So this is called closed source operating system. Closed source operating systems do not allow you to look into the source code. You cannot read it. Of course, you cannot change it. If you cannot read it, you cannot change it. You cannot change it. That means you cannot change the functionalities of these operating systems. You cannot customize it. You always need to depend on the company that developed this operating system. So Mac is closed source, Windows is closed source, Unix is closed source. By the way, there's maybe one or two type of Unix operating system that are now open source. They allow you. So there is a closed source. So the other term is the closed. The other term is open source. Can you guys see this? So if the operating system is open source, it allows you to read it, read the source code. You have access to the source code. You have access to the source code. You can read it, you can change it. You can customize the functions, characteristics of the operating system. So which operating system is open source? Which one? Which one we know? Ladies and gentlemen, it is Linux. That's the whole idea. Why this is the darling of the cloud. Why? Because, hey, if I'm a company and if I am building something based on this operating system, I should have the option to read it, to change it, customize this according to my need. Now, these companies, by the way, Windows, Microsoft, and Unix companies, they charge you money to customize. They will customize it for you. They're never going to give you source code. They believe in holding on to the information. So Mac will never give you the. You want to change something? You are another giant company like Amazon, and you want to build your own cloud. Who are you gonna pick? You're gonna pick the closed source or source code, open source. Obviously, you're going to pick the open source because the ability to customize the code, to rewrite the code if you need to. Does that make sense to you guys? It's open source. That's why this baby is the darling of the cloud industry, is the backbone of the cloud industry. Now, if you are a programmer and you wanted to write an application, you wanted to create a program, yeah, maybe some sort of shadi program that allows two people to connect on your platform. By the way, there's no good shadi platform exists today. I believe, I feel like there's a lot of young people that cannot find the right people for themselves. So I think I'm going to come up with one. So I'm going to be doing survey. You guys are going to be part of that survey. We're going to figure it out how to connect these two parties together and make sure that they have a beautiful life. A lot of the marriages are having problem today because, hey, nobody paid attention to this. So believe you me, folks, we have $1 billion idea right now. And if we all work together, we're all, individuals. We come from, I hope my wife is not listening to this. We all come from versatile backgrounds. Some of us are single, some of us are, so we're gonna work together. We're gonna develop this application from ground zero. So first thing we gotta learn is the Linux operating system. So now if we were writing this application, if we were to write a beautiful web application for the couples to, bring together to get married, then what operating system would you choose? A closed source or a open source, and why? Why are you going to choose open source or closed source? That's the question I have. Hey, open source. Because if we need to add a functionality to our operating system for that's going to meet the requirement of our application, we can always open the source code, hire a bunch of developers. They can go into the source code and they can make modifications, and hey, change the code a little bit here, 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 there, close it again, and then run our application. Do you understand why cloud industry is embracing Linux operating system? Do you know that? The good news. Do you know that the industry market share still belongs to this guy? This is dying dinosaurs, by the way. Nobody wants to play with this anymore because the companies that was giving this operating system, they are old, they don't have money, got crushed by Linux. Their big competition is Linux. This is called dying dinosaurs. By the way, on the interview, somebody's going to ask you, do you guys know about Unix? Are you have come across a Unix operating system, and have you worked on any Unix operating system? There's a one phrase you're gonna throw at them, and it's gonna give them a shut up call. Unix is the dying dinosaurs. Who wants to deal with that? And they're like, "Oh, this guy knows what he's talking about." So don't mess with him on the Unix part. Unix is closed. No more questions on that. So Unix is a dying dinosaurs. We don't deal with that because the companies don't have the money to maintain that operating system. It's old. It's obsolete. Linux has killed it completely. Linux is also now attacking Windows because till this day, Windows has the biggest market share and slow because it was so much deeply rooted into the organization. Yo, Rick, in your organization, did you have mixed environment, or did you guys heavily rely on Linux? Rick, where are you, man? I'm gonna give you a microphone because you have a lot of experience here. I'm gonna give you a microphone. So the environment that you were part of, did you have any Unix? Did you have any Windows over there? What part of the industry you were?
Um, so I worked for a company called United Launch Alliance, and they kept a Solaris system around because it actually could compute better than Linux until about 2 years ago. And then we phased that one out.
So is this the right statement that Unix is a dying dinosaurs?
Unfortunately, yes.
Unfortunately, you say that because everybody loved Unix, right?
They were so Unix was more reliable and it had better tools.
Yeah.
Linux is just starting to see the effects of making tools. So it's coming along, but it still has a long way to go compared to what used to be. But it's like, I would say Unix is like a classic car. There's always going to be people that want to see it, but it it's like you said, too expensive. It's not been really developed. It's not been kept up. So it's going to sit in a museum somewhere.
Yeah. I started off with the Solaris 7, I believe, or 8 at that time back in 2000. And I was a certified Solaris 8 system administrator. And then I just, transitioned into Linux world because AT&T got rid of not all of their Unix, but most of their Unix and replaced all of their servers with Linux CentOS, and that's what we were running in a research center. So yes, thank you for giving
I
me the
started
input on
with
that.
Solaris 5.
Oh, Solaris 5. Okay, wow. Yes, yes. At that time, Solaris 5, and then Solaris 8 was very popular. Okay, excellent, excellent. You have strong background, man. Very good. So, thank you, Rick. So yeah, Unix is, you're not gonna see that a lot in the environment. Windows, um, it still has some market share, and Linux is slowly going to take over the server market share. Do not get me wrong. Me and you, regular users, will continue to rely on Windows and Mac because we want beautiful environment. We want to deal with easy things. We don't want complexity. Even though Linux gives you that beautiful environment as well, it's meant to be a server operating system. But all of the IT industry developers specifically, their first choice of the operating system is Linux because it gives them tools to develop their applications. Okay, so because Windows has a very aggressive marketing strategy, and they give a lot of perks, to the companies to adapt to the Windows operating system and to continue run Windows operating system. And I kid you not, I used to directly work for the CTO, Chief Technical Officer of AT&T Labs. His name is Hossein Eslam Bolchi, one of the top-notch guys in the industry. And once he made a statement, and I was in his office at that time. He said that he gave an interview. You can probably Google that somewhere. He said AT&T is considering to replace all the Windows machines with the Linux operating system, and it almost cost him his job because Microsoft is bully on the block. That's why it's taking some time. Okay. Yes. Now that you understand the importance of the operating system and what it does, it is now, we understand as of now that the biggest difference between the Unix, Windows, and Mac versus Linux is open source. It allows you to read the code, modify the code. Therefore, the cloud providers like Amazon Web Services and Microsoft. Hey, Microsoft, did you hear me? Microsoft decided to use Linux to build their cloud. Did you hear me that saying that right? Microsoft is using Linux to build their Microsoft cloud, which is called Azure, however you want to pronounce that. Okay. Yeah. So now, why learn Linux? Well, Linux is central to powering servers. You know that. I've been talking about servers. Servers are the um, center point in the data center. They are the heartbeat of the data center. and they run on operating system. So choose Linux. Simply, understanding Linux opens doors to technology and innovation. 100%. If you understand Linux, you will understand rest of the technology, the other branches of technology. If you know how to work with Linux, you can adapt to anything. You want to learn cybersecurity? I was surprised. Abud was telling me yesterday on the microphone that he's learning cybersecurity, SOC analyst, and he's not learning Linux. How do you do that? How do you got to protect the Linux operating system, then you can protect the applications. If the Linux operating system is not protected, most of the applications run on Linux. So without learning Linux, you cannot become a cybersecurity specialist or engineer, let alone analyst. Okay. So it's a very crucial skill in the age of digital transformation. We're in the digital age now, you know. By the way, the robots that are going to take over, they also run on Linux. The autonomous cars are also running on Linux. So, it's embedded in there. So it's going to be used everywhere. Is Linux secure? 100%. Even though now you might think the Linux is open source, how is it secure? Anybody can take the open source and modify it and add some code over there, close it up and say, hey, okay, take it. That's not how it works. Every company that uses Linux, because Linux, this is important for you to understand. Come back over here for 1 second. Because Linux is open source, can everybody go and modify the code? Well, everybody can download the code. No, wait. Everybody can download the code into their machine and change the code that they have. And now they can create their own Linux. Yeah, you can download Linux and you can call it, hey, my Linux, or whatever Linux you want to call it. But then how do you sell this to the consumer out there? Because the market player is Red Hat. This is what they did. Initially, they took the code, they modified it, they added their own stuff, they made it more beautiful. And now their version of Linux is called Red Hat. Now you understand why there are different distributions, different flavors of Linux. Just like the ice cream has flavors, Linux has different flavors. Red Hat, Oracle, Enterprise. Hey, Rick, what type of Linux? Oh, you told me yesterday. Red Hat. You worked on Red Hat. Oracle Enterprise. Ubuntu. SUSE. I think it's SUSSIE, something like that. SUSE. Kali Linux. CentOS Linux. What else? What else you guys know?
SE Linux.
Which one?
SE Linux.
Oh, SE Linux. Yes. So now you see, you have there's a Unix. There are only 3-4 type of Unix operating systems, right, Rick? 4 maybe. HP, yes. Solaris, IBM, 3-4 good. But Linux is exploding because every person can download open source Linux and they can customize this and make it their own Linux. But then the issue is, so no, you cannot download, you can download, you can change it, but you cannot push it back to SE Linux or CentOS, Kali, SUSE, Ubuntu, Oracle, Red Hat. They will not take your version. Why would they take your version? They have their panel, which will review the code, and then they will accept the code. And they have their own type of programmers. And if you're a community member that wants to contribute to their code, you want to improve their code, you can write them an email saying, hey, I think there's a problem with your Red Hat open source code. I would like to contribute. They will say, okay, go ahead, send me your piece of the code. We're going to review it. If we like it, we will add back to the Red Hat. But it's so therefore it's highly secure, it's open source. You can download the main kernel and you can play with it. And if you're an organization, you want to call it something else, you can call it something else. But that's why Linux has so many distributions, and it's very difficult to track now which university, which distribution is good for your company. So therefore, companies, enterprise companies like Google, like not Microsoft, Amazon Web Services, they have decided to come up with their own type of Linux. But banks, JP Morgan Chase, Bank of America, they like to work, and the government, United States government, they like to work with Red Hat. So now you know what I have been talking about. Red Hat. What is this guy talking about? Red Hat, Red Hat, Red Hat. Red Hat is a company that created their own Linux, and they called it Red Hat. And the short name for their operating system is RHEL. Red Hat Enterprise Linux, RHEL. So when you go to the interview, the manager will ask you what Linux distribution you work on. If you say Red Hat, no, it's not accepted. If you say RHEL, it's accepted. That means you know what you're talking about. You know, if you don't know, you don't know. I asked Rick the other day, who has 10 years of experience in Linux administration, I asked, hey, what distribution you work? He goes, RHEL. That's how professionals talk, and that's what we're going to teach you, how to talk professional. Where are you going to learn this professional lingo if you don't have a mentor? Udemy is not going to teach you this stuff. YouTube is not going to teach you this stuff. They're just going to teach you Red Hat Linux. And you go sit in front of the interviewer and say, what distribution you work on? I work on Red Hat Linux. Like, okay. You know. If you don't know, you don't know. Okay. Okay. So we're going to talk about why Red Hat is popular. Okay. But other than that, let's continue. I think we are running a little bit short on time because I talked too much today, and the real inner me is popping out, and that's a good thing and a bad thing too. Um, so let's talk about this. So it's open source, allows for constant auditing and improvements, of course. Strong user privileges, root access, you don't know what that means. Software mainly installed from trusted, you don't know what that means. Active community, yes, active community. Vendors, regular support vulnerabilities, yes. Don't worry about that stuff. Okay, the opportunity of learning Linux. Why is it important for you to learn Linux? Over 10,000 job openings requiring Linux skills. I'm not saying the 10,000 jobs are Linux administrator or Linux engineering jobs. They could be security related, they could be DevOps engineering, they could be SRE, they could be cloud engineer. Can you become a cybersecurity specialist without learning Linux? No. Can you become a cloud engineer can you become a cloud engineer without learning Linux? No. Can you become a site reliability engineer without learning Linux? No. Can you become a good application coder without learning Linux? No. Is that right, Rick? Absolutely no.
Correct.
Yeah, so enhance your IT career with in-demand expertise. The good thing is we're going to teach you Linux for free. Some of it. AI era will drive trillions in new data centers. As AI is growing, we need more data centers because more information is going to be collected from you guys. And as the information grows, we need more data centers to process the information. Therefore, the data center's darling is Linux, along with other things. It's the backbone. The cloud industry's darling is Linux. Now, this is the CEO of Microsoft is saying Linux is the best operating system to advance the development in of generative AI. Generative AI. I don't know if you know what generative AI is. I will talk about AI and its impact on the industry in some other day. So then we will talk about AI agents, generative AI. And I'm going to tell you how you're going to use the AI in everything that you do today. Don't be afraid of the AI. Adapt the AI. Okay. Amazing ways Linux changed the world. So NASA uses Linux simply. Inter- Linux runs the internet. Servers for Google, Amazon, Wikipedia, Facebook all rely on Linux. AI is hands down all Linux. Okay. Enables smart cities. Dubai, now New York City, smart cities are all backed up by the Linux because it allows you to customize the code. Exciting Linux facts. Empowers world's top 500 supercomputers. The top notch 500 supercomputers that exist, they're all running Linux. It is the foundation of many smart city infrastructures. We already talked about that. Linux is an integral to numerous mega projects driving innovation. Yes, I've seen that at AT&T Research. Any innovation that's taking place now, Linux is the backbone. That's their platform. You have to understand, Linux is the platform. Everything sits on top of Linux. Okay. Why learn Linux again? Widely used in servers, supercomputers, and smartphones, open source, and customizable operating system. Tools for experts and developers to explore. Flexible, stable, secure platform for various applications. Application developers, they love to work with Linux. They're geeks. Excellent career opportunities in IT and beyond. And another thing I'm going to tell you why learn Linux? Because it's a little bit difficult to work with. You will be working with the black screen. You know how the hackers do it, like a black screen, and you don't see anything else. There is no graphics over there. So you'll be working with the terminal, you'll be working with the shell as soon as this Wednesday. Not everybody can do that. Not everybody has the aptitude to learn to adopt to that. The way we're going to teach you is going to be the most simplest way, and you're going to become subject matter expert in this domain. In my opinion, if you want to live life in a respectful way, if you want some power, you need to have something that you conquer in your life, a skill. For the past 25 years, I have been employed. I have never had to worry about my bills. Never. My Easy Pass, my electricity, everything gets paid automatically because of the skill that I learned 25 years ago. All right. Now, I think we're going to stop over here because most of you